I'm here in Tolland, Connecticut at Inductive Autoworks, and tonight they're at an open house where they've offered to go on camera with me and answer some nerdy questions. And I'll start with names and kind of your roles here at Inductive Autoworks.
Sure, so I'm Jonathan Untied, and I'm the president and the chief software engineer.
Thank you.
My name is Dennis Manning. I'm a co-founder and lead electrical engineer.
My name's Joe Monasky. I'm the third founder of the company and the lead mechanical engineer here at Inductive Autoworks.
Cool. Whoever wants to hold the mic, maybe get started with showing me a little bit about what's on the table here, and we'll get into CNC, and then there's a car over there in the lift we'll end with.
Sure.
Thanks.
So what we have here is basically an exploded EV. We took all of the critical parts that are put into an electric vehicle, and we spread them out on the table here so you can kind of see what goes into making an EV that you wouldn't normally see in a gas vehicle. We got everything from the critical lithium-ion battery pack, or any battery pack really in an EV, all the way to the electric motor and inverter that is actually driving the wheels.
So this happens to be a Tesla part that you have on display.
That's right.
You've got a whole bunch of brands and Leaf, and you got all kinds of stuff coming up, right?
There's a mix of brands. There's a couple of items here I'd like to draw out, which is one is we have our custom integration controller here, which is basically a unit that allows you to set up something to have all these different pieces of the EV communicate with each other and communicate with the car that you're installing them in on a conversion. Normally, when you get these, like you mentioned, from different manufacturers, they don't work with each other out of the box. There's some work to be done there. That's what this helps you do.
Could you tell me a little bit about the PCB and design and who does that? And you got the software skills right in-house?
Sure, yes. So I do the embedded software design. Dennis is our electrical engineer, so he actually populated the PCB and worked on the PCB design. We also have a contractor, Dave Vold, who helped us design the PCB. And did the layout, that's correct. And then we actually, sent it out to have the PCB made and whatnot. So we kind of worked as a team to develop it. And Joe actually designed the box that's in and cut that lid.
Nice. I actually made the lid here too, the fancy graphics. Cool.
Yep. There's the connectors on the side there.
Yep. The interface connector as well.
RS-232, ancient, old school.
Yeah, I mean, it's a prototype. So I mean, honest, that's not going to be the final connector, right?
Okay.
But that's a prototype, and as you probably noticed, not all the wires in there are hooked up yet, but we're kind of just showing off what we're doing. So also, this unit here is kind of an Inductive Auto exclusive item because we worked with another company to source these, and they basically are better than pretty much anything that's out there on the market today right now. This has an integrated DC-DC converter, which is what generates your 12 volts in your car, essentially replacing your alternator. And then it also is an onboard charger, which is what's taking your AC voltage from the wall and bringing it up to that 300 plus volts that your battery pack is. When you use this plug and you plug it in at your house, this is what that plug's connected to, and that's charging your battery.
You okay if I pop these off for a second?
Yeah, we can pop these off, sure. You can see they're high voltage connectors. So one side is going to be the DC side, I believe. That's this side, and then the 3-pin side over here is the AC side. And then this is going to be your 12 volt output here, and then there's a control connector right there.
It's a water-cooled system?
Yep, it's water-cooled. It's fairly compact for what it is. I mean, I know it looks like a big unit, but when you think about it replacing two things, it's actually pretty compact. And it's certainly good value compared to the prices of pricing out these individually and then trying to figure out where to fit them. So we don't build this, we source this, and this is kind of something that you basically can't get except through us right now.
Okay. So this one's designed more in a
this is ours from the ground up. This is something we're sourcing that's going to be part of our kit, and is kind of an exclusive thing that we provide as part of the kit, and a la carte. But
all right, and as we go around, maybe you can tell me more about what you actually do in the CNC too.
Sure.
Over there. Okay, cool. Anything else you want to highlight here? Whose throttle is this?
That throttle is actually a Tesla throttle.
Okay, I just saw a video on that from some teardown. What is his name of a YouTube channel? But yeah, the inside of this thing too.
Yeah. I mean, honestly, a lot of electronic throttles are pretty similar, but that's just a good example of what you would see in an EV.
And compressor, this is heat pump days, and super bottle, this is some other brand. What is this?
That's actually a Nissan Leaf compressor. That's an early model, as you noticed. Obviously, heat pump would be more efficient, but it was easy for us to show that you could have a cabin heater, AC compressor. These run on high voltage. And that's a little more efficient than trying to step it down to 12 volts. And obviously, without a gas engine, you don't have the heat to scavenge to warm your car up, you know? So you have to use the high voltage to generate that heat.
Okay. And then you have a BMS that's also off the shelf, I guess, from...
Yes, this is an Orion 96 BMS, right? Orion Evert Energy Systems, based out of Longmont, Colorado. They make by far the best BMS that I've ever used. What we do here, right? We buy the BMS. You have your batteries that you're using for your conversion. You need a couple things, right? You need a cell tap harness. It's critical that this is built properly to make the connections between the BMS and the individual cells of your battery pack and make them securely. Taking care of every cell while you're driving down the road is the job of the BMS, and without a properly built harness, it isn't going to work as needed. The other thing that we provide is the programming of the BMS, right? Every application has different use cases, has different limits on the batteries, on the charge rate, discharge rate, temperature, and so on. I have 8 years experience programming these BMSs, good relationship with Evert. We can provide fully documented and programmed BMSs for your EV conversion.
So with that experience, you're coming up with basically heading towards maybe something like a kit. I mean, that's an RX-8
Absolutely.
as a start.
Absolutely.
But you've done this a number of times, and you eventually come upon what kind of cells, what brands you want to use, who you trust, all that good stuff.
You're hitting the nail on the head. It is, experience that we have, not always in the EV industry, maybe in similar industries, that gives us the knowledge to promote certain products over others. Right, we really know what is reliable, what's gonna perform well in your car.
Off camera, you and I talked a little bit about safety and some other approaches to some other videos you see out there.
Exactly. Thank you for bringing that up.
Yeah. So if maybe that's one of the things, we'll look at the high voltage stuff.
Yeah.
Oh, sure, yeah.
Yeah. So I think what I was trying to convey is the idea that doing a conversion on your vehicle, right? There's a lot of corners that can be cut, and we're trying to promote the idea of using all of the safety options available to you while doing your conversion. The OEMs, right, the manufacturers of electric vehicles, they have implemented a series of significant safety features that we think are very important. Some examples are, here we have a safety disconnect, right? This is a device that allows you to physically disconnect the battery into two halves, right? So that allows you to open the circuit and completely remove any potential from the remaining, from outside of the battery box. This is usually placed on or near the battery box to allow you to basically say, there's no voltage leaving this box. The rest, everything outside of this box is potential free. The contactor that we use is a very important piece of the safety system. We've noticed there's some do-it-yourself EV conversions out there where underrated contactors are being used. People are trying to use contactors in parallel, things like this that we really would like to promote use of the proper product for, for the application. We've tested a lot of contactors. We've blown up a lot of contactors. We have a lot of experience in this regard, and we know a good product because we've tested it. Going along with the contactor, and just to be clear, the contactor is what connects or disconnects your battery from the rest of your vehicle, right? It's your on-off switch for the output of the battery. It's controlled through a number of means, software, hardware, and otherwise, and one of the most important means of control that we would like to promote is high voltage interlocking. High voltage interlocking means a very small 2-pin connection being present at every disconnect point where a plug plugs into a receptacle. By having high voltage interlocking in your system, you can be assured that when you physically disconnect, whether it's intentional or not, that your contactor will open. If you break this connector by disconnecting it or it getting a rock jammed in there or anything like that, the signal that is closing the output of your battery will be removed, and you will no longer have voltage flowing down this cable.
That's present on every OEM.
Yep.
And
So
almost no conversion we've seen.
Yeah, it's important to mention that the HV interlock is a standard feature on every factory car, every factory EV that's coming off the factory floor right now. So this is something that every major manufacturer has recognized the importance of, but is virtually non-existent in the DIY world. And that's something that we're hoping to bring the knowledge and bring the product support to people to help them not only do conversions but do them safely, because there's certainly a level of danger here if you don't know what you're doing.
Sure, and backing up a little before we move on to the tour, just I'm imagining someone who drove this car maybe 20, 30 years ago in their youth and is just reimagining it 500 pounds lighter. That's what they're excited about, using a shop like yours so they don't have to worry about oil changes and weekends when maybe they're only driving 500 miles a month anyway, right? Minimal miles. So I think that's the dream I'm seeing. People, you're making that dream come alive for people.
Right. And
repurposing what they got.
And you think about an even older vehicle too that has a carburetor that you got to retune every time the humidity changes. You put an EV motor in there and you can just get in that car and go. It makes it more usable again, right? Exactly. Now you don't have to worry about the fact that your ancient V8 gets 8 miles to the gallon. You can drive the EV version of that car to work every single day and enjoy it every day instead of once a month on a select Sunday.
Yeah, that's awesome. And the other thing, like my dad had an RX-7 in the 80s. It was kind of heavy, and the rotary really needed to spin up before he had any power. I can imagine a torque curve that is a lot flatter now. That is a whole lot more fun.
It's not so much as a curve as a line. It's a straight line from 0 to 4,000, which is just pretty awesome. And trying to compare that to a gas motor, there's almost no comparison. The numbers really aren't one for one when you're talking about an RPM at 0 RPM, or torque at 0 RPM.
So if the magazine or article highlights horsepower and torque and they don't show you the shape of the curve, you're not impressed. You want to
you really got to see the curve, because 1,000 horsepower and it's all available at the top end of your motor where you never get there, and you're slugging to get there. It's not usable power. So we really try to talk about usable power, and EV does a really good job at bringing all that power down into that usable range.
All right, so maybe we could look at the, we got one more motor, a CNC briefly, and then show me the actual cars.
So this real quick, this is the inside of a Nissan Leaf gearbox. We're just kind of showing this off to show. Kind of the cool thing to talk about here is really this is the extent of the moving parts in an EV. You have, whether it's a Tesla or a Nissan or whatever it is, if they're running a gearbox like this, which pretty much they all are, powered directly to the wheels, really this is the number of moving parts in your car. So you're looking at a few bearings, a couple gears, versus the thousands and thousands of parts of an internal combustion engine. And really what that boils down to for your average car owner is virtually no maintenance. You got to change your gearbox oil once maybe in the lifetime of your car, and that's effectively it. Other than that, the car just works. There's very, very few moving parts. Less moving parts means less maintenance and less cost every day.
It is funny you mentioned lubrication oil. People rarely know that Teslas actually have oil.
Yep.
It's funny, they say, everyone says no maintenance. Well, it's a little, but generally, like you said, life of the car.
Exactly.
All right, I've seen a number of videos of this coupling, how important that is between the old and the new.
So this is a new product. This is a really early prototype right here. You're probably the first person to ever get this on camera, so breaking news. This is something we're developing to work with a more traditional layout of a gasoline car that has either a solid axle or a rear diff or something like that. And what this allows us to do, this adapter right here, allows us to mount an electric motor either to a transfer case. So this is from a Jeep Cherokee, so a four-wheel drive application. So this mounts right to the OEM transfer case. So this can go in the stock location, stock drive shafts right out to your wheels. And then all you have to do is this whole system right here mounts in the place of your stock transmission. So transmission's gone. Gearbox reducer gets your electric motor in the right RPM range to work with the ICE components. And now you have your entire engine bay, because this system right here sits in the tunnel. You have your entire engine bay open for a nice square battery box in there. So this really helps eliminate unneeded components. You don't need a transmission in an electric vehicle. You need one gear. Reverse is all handled electronically, so that's really just, it's wasted spinning mass, robs you of efficiency. And this makes it much more compact and allows us to have a fairly universal product that all you need to change is this interface here to adapt it to pretty much any vehicle. And if you're talking about a two-wheel drive vehicle, it's just a flange, so it's very minimal differences between chassis to mount that up to your rear wheels.
So nice transition into CNC milling, right?
Yeah,
That's what I'm looking
yes,
at
this
here.
is,
And there's
this
what's
product, as well as any other machine products here, is totally developed and produced right now in-house. This is a machine we purchased this year. This is a Haas Vf2 3-axis CNC machine. So this allows us to do CNC machining in-house. Prototyping is really where this thing shines. I mean, the ability for us to, when we're building that car, to see a problem, take it over to CAD, and have a part in hand in hours instead of weeks is pretty phenomenal. And then the other side of this system too, which you're kind of looking at here, is the reverse engineering side of it. So this probe that's in the machine right now is able to pick up the location and holes and surfaces, pins, that kind of stuff, within 0.005 of an inch. So the way we developed that adapter bracket is put the existing part on the machine, use the machine to probe the locations, take that data back to the computer, draw it up in CAD, put a square block on here, and then cut out that shape. And that whole process can be achieved within about 4 hours.
Wow.
And that's hugely advantageous versus the traditional process of measuring it with calipers, rulers, that kind of stuff, sending it out to machine shop, wait a couple weeks, get it back, see that something's off a little bit, tweak it, do it again. We're able to hit stuff much, much more frequently on the first time because of the accuracy of that system. And then if it does need tweaks, it's a matter of bringing it back over to the machine and not waiting another 2 weeks. So there's certainly cost savings of having this in-house, but the major benefit of having this in-house is the time savings. We're able to rapid prototype and rapidly turn over builds.
So you know a customer, maybe they put down a deposit and they're coming in a few weeks. You get started with the research of getting whatever vehicle they have and getting that thing made in advance?
Absolutely.
Okay,
absolutely.
that makes sense.
That's the kind of stuff that we can get started as. You know, we need something to go off of. We have to have some part to measure off of, but that doesn't have to be a whole car at the beginning. You know, at some point, we can talk about this a little bit more when we get over to that car.
Yeah,
we do have
let's
to
head
do
over.
significant measurements from the stock original chassis. But as much of that as we can do in advance and breaking it down to smaller chunks and being able to measure them more accurately in the machine and other methods like 3D scanning as well, which is technology we're looking at using as well to continue to speed up this process. As many times as we don't have to redo work and redo parts, all translates back to cost savings and quicker turnaround.
Help me out with what year this RX-8 is from Mazda?
It's 2005.
Okay. And the weight savings, I was pretty impressed. Someone said 500, is that?
Yes, it is 500 pounds
That's
lighter
incredible.
than the original car. Now, I will say the caveat with that is that this battery pack is not as big as we would do if a customer came and asked us for a conversion.
Now it's so tight in here, you didn't have any real choices on center of gravity and all that, but tell me about front to rear weight distribution before and after.
We did keep the perfect 50-50 weight balance. It's within I believe maybe less than 10 pounds. It's pretty close, whatever it is. Yeah, it's certainly within 1%. It's within 1% on our corner scales. So we kept all the handling characteristics the car originally had. And the other thing we did when we did the conversion is we didn't do any significant modification of the chassis, no cutting of the frame, crash areas, or anything like that. We intend for these conversions not to affect the original design of the chassis and the suspension of the car in any way.
We want to work well with what the manufacturers did great from the beginning, and particularly on this car, they built a really well-handled car, well-balanced car that handles well, does great in the corners, and we want to make sure we maintained that well as modernizing it, putting a better power plant in it, and making a more fun, more modern car out of it.
Ever thinking, or companies are going lithium there? Is that a way? I mean, it adds some cost, right? Probably $200 or $300 lost right there.
Yeah, I mean, that's a motorcycle battery, and so it's all it really needs to do.
We're talking about the 12-volt starter.
Right, that's
accessories.
when you turn the key.
Exactly.
It opens all the circuits and starts everything up, and then that's all it needs to ever do. So we probably could have gone even smaller if we wanted to, but you know, that was just that was a quick, easy solution for us to get that 12-volt system up and running from the beginning.
All right, well, we'll have a look. Maybe you mentioned you could lift it too, but tell me what's inside the box before we lift it. So what magic are we seeing here? We got 2 boxes, I guess, it looks like.
Yeah, the rear box.
thanks.
The rear box here, right?
Yep.
It contains 6 of the modules that are produced by LG Chem. Right,
Okay.
they're 60 volt. How many kilowatt hours?
It works out to about 18.
18 kilowatt hours in total. I apologize. I've been talking all day. I didn't have
No
that off the
problem.
top of my head. And so these in total, our thick 360 volt lithium pack, right? And you can see right in front of it, we have kind of the battery management and safety suite, right? And under this cover, we do have our safety disconnect right here. We have our contactor underneath, and all the safety systems that revolve around the battery itself are all contained in this one box. The output of the box are these two wires and obviously some control signals. All of our safety systems, right, when they activate, they will basically kill the power, leaving those two large gauge wires there. Directly in front, we have DC distribution, right? And when I say DC distribution, I'm referring to the high voltage DC, the 360 volt DC system. All of that is unique in how it is applied. So we have the unique connectors needed to handle the 360 volt DC distribution. We have the contactors, we have the relays, and obviously the control circuitry to power the systems which require that voltage, the inverter, right? The DC to DC converter, which is inside this box as well. The DC to DC converter, critical component of an electric car, right? It takes your 360 volt DC battery pack and converts it down to 12 volts with 100 amps or so behind it to run all the 12 volt systems that already exist in the car, right? Windshield wipers, headlights, all those things. We're not trying to change all those to run on 360 volts. They run on 12 volts as they always did, and you just have your DC-DC converter in here to power all those systems.
Quick question, I'm kind of naive about any kind of retrofits, but if you have an accident and airbags go off, is there any way to have a fuse blown so there's an automatic disconnect to the high voltage system? Or?
Absolutely. So
okay, cool.
An impact sensor, right, is what would trigger an I/O pin to the BMS, and in that moment, with the BMS noticing that sensor being triggered, it would kill the output of the battery.
Awesome, thank you. All right. Is there anything to show in the trunk before we lift it, or?
It's empty.
Check out the
Oh, okay.
door.
So
Yeah.
the trunk is useful. That is something to show. And the rear seats are normal too.
Yep.
I mean,
The
I mean
interior
small,
of the
but
car is effectively the same.
cool. Yeah, and hold a little closer too. There we go. We put the connector in the right spot.
Connector in there. We
Nice.
wanted to keep as much of this car stock as possible. Kind of the goal of this car was to build like a sleeper EV. The car interior is virtually unchanged other than the gear shifter. You can't tell this car is an EV from the outside at all. That was kind of the intent. We wanted to put that right in there. Your fuel still goes in the same spot, different fuel.
J1772.
Yep,
Okay,
that's correct.
So AC charging, not DC.
Yep.
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 Just point that out. All right. And then what's different on the dash? Some stuff in the center console, I see.
So the only change in there is we took the lever shifter out and put the rotary knob in there. It's something we're playing around with, different shifter types, but that's what we're at on this one. Do you want to talk the gauges a little bit, John?
Sure. So one of the products, the integration controller that I mentioned earlier, there's an early prototype of that in here, and that actually allows us to drive all the factory gauges as if it were the original car. So when you start this up and you start driving, it tells you how many miles per hour you're going. You actually see an RPM gauge. We're still working on it, but the fuel gauge will eventually show state of charge. But pretty much the warning indicators, they all work. All of that, it works as if it was the factory car.
Who makes that stuff that makes that interface happen? Or
We make that.
you make all of it?
We make that from scratch, yes.
So that's like a nascent industry. Obviously, other companies must be doing something similar, but you're building up a library of cars that you're getting used to retrofitting.
Yeah, I mean, I can't speak for every other converter, but what we've seen traditionally is they tend to just add on other electronics. So
Okay,
you end
rather
up,
than original.
rather than
Yeah.
modifying the original, they'll just give you more gauges to look at that represent the EV controls. And we want our conversions, as Joe mentioned, to feel like the original car and to have that same quality level. So we try and retain all the original instrumentation as much as possible.
So you're going for more purists, and they might be driving from like anywhere in the country because they want you, or you got a broad audience? Or
That's
the goal,
yeah,
right?
yeah.
Because they want the original instrument cluster, maybe.
Yeah,
they'll wait for an appointment with you, maybe.
One thing to mention is we do ultimately plan on replacing the radio with a more informational heads-up display, because there is a lot more information you get out of EV systems.
2003, yeah.
And we'd like to provide that to the user, but in kind of like a more subdued fashion than just having a bunch of gauges all over the dash that say different things.
Okay, got it.
Sure.
Oh, yeah.
Yeah. Yeah, look, I mean, it's mostly usable trunk. We did have to make some modifications, so the carpet doesn't look beautiful right now. And then the only real EV part that's in here is the chargers down here. I would say the wheel well normally on a car, but the RX-8 didn't have a spare, so this is just kind of a dip in the trunk that it's in.
Okay.
But it's
completely usable, yeah?
Yeah, it's completely usable space. So we're going to pick it up.
Back up.
So what you're seeing here is our custom rear subframe that was designed in-house here by Joe. And then this is the Nissan Leaf motor and gearbox that's mounted within the subframe, connected to the wheels via custom axle shafts. We've got back here, this is the original Nissan Leaf inverter. So that's actually providing that variable frequency control for the motor. And then we've got a high voltage connection. Actually, the other end of it you saw in the engine bay. That's coming back here. And there's a tap also for the charging system. You can see that it's still factory suspension, all that's unmodified. Obviously, the subframe was heavily modified, and I'll let Joe talk about that a little bit.
Yeah, so we started with a stock subframe, and then really with the goal of keeping all these frame mounts and all these suspension mounts in the exact same spot. So a lot of bracing, a lot of mock-ups, a bunch of custom designed parts here. This front add-on was some laser cut parts that were custom designed in-house, and used to kind of bring the subframe forward a little bit, but still maintain these factory frame points on there, so we could keep the suspension geometry all the same. And I think what's really exciting about under here is what you don't see. There's no transmission, there's no drive shaft, significant reduction in spinning parts, which means significant reduction in drivetrain losses. We have
giant empty space
right,
in the middle. No
gearbox,
fuel lines.
Exactly. So the gearbox over there, so that gearbox is the extent of the moving parts, and then power directly to your wheels. So about as close as you can get, other than probably hub motors, to no drivetrain losses.
And maybe we could finish up with a bit of thermal management, because I do see that.
Yep.
Right?
Yeah. So cooling lines front to rear. Pretty much all that's in the transmission tunnel right now. So
What's it cooling though? Transmission, and it's got to cool anything else back there?
The motor,
There we
the
go.
inverter,
Thanks.
and the charger right above it are all liquid cooled.
And there's the cable. Okay, I see
Yep.
the plumbing. Black cable.
Yep. And then all it runs through an electric water pump up at the front there, and uses the stock radiator. So we made some custom adapters to adapt the EV cooling lines to the stock radiator. And it just uses the exact stock cooling system, other than that pump on there. So again, with the goal to use as much as possible, and anything that we didn't have to throw away and replace, we tried to keep.
I see the high voltage lines tucked as far away from the road as possible.
Yep, try to keep those up and out of the way, and protected, rated cable, so correct jacket on there, so it's waterproof, it's sealed, abrasion resistant, and then the additional abrasion resistance of the corrugated line on there as well.
So is this a finished car or almost finished, or what's this?
So the goal with this car is that it'll never really be finished. This
Okay.
is a company-owned car, and this is really our test mule. So this car will probably see several different motors, different battery packs as we test different products and test different stuff out with this car. We built it to be fairly modular. So like Dennis or John mentioned earlier, we didn't want to cut up the frame at all. So it's basically, if we really wanted to, we could put this back to a stock car. But the point of this is to be able to unbolt components, bolt different components in, and use this as a test platform to try out different products and being able to vet stuff before we offer anything to a customer. We want to know it works, we want to know how it works, and we want to be able to answer your questions when we get a tech call.
So one subtle difference on an actual customer car driving out of here, they probably have more shielding or something on the bottom.
Yeah, I would probably do a little bit,
Yep.
more under here.
Depends
and
on
then,
the car and-
right.
Less empty space.
Like we mentioned, if we were going to do this a car for a customer, we would probably put a second pack in here, utilize this gas tank space as well as this tunnel in here to get more range out of it and keep that center of gravity.
The tunnel here, you could fit a whole lot more cells as your point.
Yeah, we
right?
figure we could probably about double the number of cells in this car with the available space, and probably get even a little bit more out of it as battery technology advances.
And to keep that 50-50, it'd be somewhere near the middle.
Yep,
Yeah.
exactly. So if we kind of use this space, keep them all right in the middle, we should be pretty good right in there.
So you said factory radiator right there.
Yep.
Yeah. Wow. All right. Well, thank you so much for all your time. I really appreciate it.
Yeah, thank you.
Great to meet you, especially right here in Connecticut where we all live.
Yep.
Yes.